Hello there, and welcome to the Bedtime Lab, a place where curiosity gently intertwines with relaxation, creating a soothing tapestry of knowledge and wonder. Tonight, we're embarking on a peaceful journey through the vast and mysterious expanse of the Milky Way, unraveling 100 fascinating facts about our home galaxy. So, settle in comfortably as we drift through the stars, each one a glowing point of discovery and intrigue. While you settle in, I'd love to know, where are you listening from tonight? Go ahead and drop a comment to let me know. It's always heartwarming to see people from all corners of the world gathering here, finding solace and a shared sense of wonder as we explore the universe together. As we begin to paint this cosmic picture, imagine the Milky Way stretching across the sky like a delicate band of light, a spectacle that has fascinated humanity for eons. It's a barred spiral galaxy, and did you know it spans about 100,000 light-years in diameter? This grand structure is classified as a barred spiral, a type that's less common than once thought, adding a touch of uniqueness to the galaxy that cradles us. Picture our galaxy gracefully gliding through the cosmos at an impressive speed of about 552 kilometers per second, all relative to the cosmic microwave background radiation. This constant motion is a reminder of the dynamic dance of galaxies in the universe, a ballet that unfolds on a stage of unfathomable scale. Here's something curious regarding the name of our galaxy. The term Milky Way has its roots in the ancient Greek word galaxius, which means milky circle. This poetic imagery stems from a myth involving Hera's milk spilling across the heavens, forming the luminous band that cuts across our night sky. Such stories offer a glimpse into how our ancestors interpreted the celestial phenomena above. In the grand scheme of things, the Milky Way is just one of countless galaxies scattered throughout the universe, yet it holds a special place as our cosmic home. Can you imagine within its vastness, swirling spiral arms and hidden wonders waiting to be discovered? Speaking of these spirals, our solar system finds its place in one called the Orion Arm, a small branch of the galaxy's majestic structure. Interestingly, our galactic neighborhood includes the dazzling Alpha Centauri system, the closest star system to our own, located just 4.37 light-years away. The proximity of these celestial bodies, nestled amidst billions of others, highlights the intricate tapestry of stars that populate the cosmos, many of which remain invisible to the naked eye. In fact, the Milky Way contains over 100 billion stars, each with its own story and life cycle. Some of these stars are ancient, over 13 billion years old, almost as old as the universe itself. Their luminous histories serve as cosmic time capsules, holding secrets of the early universe and the formation of galaxies. To put this in perspective, the sheer number of stars in our galaxy is comparable to the grains of sand on all the beaches of Earth. It's a humbling thought that underscores the vastness of the cosmos and our small yet significant place within it. The more you learn about these stars, the more you appreciate the complexity and beauty of the universe. The Milky Way's elegance is not just in its magnitude or the quantity of stars it hosts. It's also about the stories each star tells, stories of formation, life, and sometimes spectacular ends as supernovae. Related to this, the remnants of such stellar explosions can form neutron stars or even black holes. Let me share something fascinating about these stellar nurseries. Stars like our Sun are born in vast clouds of gas and dust, known as nebulous stellar nurseries. These regions are the cradles of creation, where gravity weaves together particles into new stars, sparking the birth of light in the universe. It's quite remarkable to think that the light from our own sun began its journey in such a cosmic nursery. As we gently delve deeper into the cosmos, we transition from the individual stars that add sparkle to the Milky Way to the swirling, majestic arms that compose its grand spiral structure. This seamless bridge takes us on a journey through the vibrant life and interconnectedness of the galaxy, where every star, every particle of dust, and every stream of light plays a role in the cosmic symphony of the Milky Way. Have you ever wondered about the very first people who gazed up at the Milky Way and began to unravel its secrets? One of the earliest known records of the Milky Way's study comes from the ancient Greek philosopher Anaxagoras, who speculated in the 5th century BCE that the Milky Way was made up of stars too far away to be individually discerned. This idea was revolutionary at the time, as it suggested a universe much larger and more complex than previously imagined. Fast forward to the Renaissance, and you'll find the Italian scientist Galileo Galilei turning his telescope to the night sky in the early 17th century. With this new tool, Galileo discovered something quite unexpected. The Milky Way was not a continuous band of light as it appeared to the naked eye. Instead, it was composed of countless stars, densely packed together. This was a pivotal moment in our understanding of the galaxy, revealing the true nature of its luminous band. Interestingly, in the 19th century, the German philosopher Immanuel Kant proposed that the Milky Way was a vast collection of stars, a stellar island in a universe populated by many such islands. His philosophical musings laid the groundwork for the future of galactic astronomy, a field that would blossom with the advent of more powerful telescopes and new scientific methods. One curious detail about the early observations of the Milky Way is the contribution of the great British astronomer William Herschel. In the late 18th century, Herschel meticulously counted and catalogued stars. He proposed a model of the Milky Way shaped like a disk, with the Sun near the center, a notion he based on the observed distribution of stars. Although we now know the Sun is not at the center, Herschel's work was instrumental in advancing our knowledge of the galaxy's structure. Here's something unexpected. Did you know that the first photographic image of the Milky Way was captured in the late 19th century? In 1880, Scottish astronomer Isaac Roberts took a groundbreaking photograph that revealed the spiral structure of the Andromeda galaxy, providing the first visual evidence that other galaxies might exist beyond our own. This discovery hinted at the Milky Way's spiral nature long before it was confirmed by direct observation. Have you heard of the American astronomer Harlow Shapley? In the early 20th century, Shapley used the newly discovered method of measuring distances called Cepheid variable star method to determine the size of the Milky Way. His work suggested that the galaxy was significantly larger than previously believed, with the Sun located far from the center. Shapley's findings fundamentally shifted our understanding of our place within the galaxy. Consider this. One of the earliest debates about the Milky Way's structure was whether it was unique or just one of many such galaxies in the universe. In the 1920s, the great debate between astronomers Harlow Shapley and Heber Curtis argued that the Milky Way was just one of many galaxies, a view that was ultimately supported by the groundbreaking work of Edwin Hubble, who later proved the existence of other galaxies beyond our own. Speaking of Hubble, it turns out that his work in the 1920s and 30s did not just prove the existence of other galaxies. Hubble also discovered that the universe is expanding, a revelation that hinted at an even larger cosmic architecture. His observations of the redshift of galaxies led to the formulation of what we now call Hubble's law, which fundamentally changed our understanding of the universe and our place within it. One of my favorite facts is about the discovery of the Milky Way's spiral arms. Early in the 20th century, astronomers began to map the galaxy using radio telescopes, which could detect emissions from hydrogen gas. This method allowed them to identify regions of higher density and revealed the spiral arm structure of the galaxy. This process was pivotal in confirming the spiral nature of the Milky Way, which is not directly visible due to our position within the galaxy. Interestingly, the mapping of the Milky Way's spiral arms also led to the discovery of an intriguing phenomenon known as galactic rotation. The way stars in the galaxy move suggested that the Milky Way spins like a giant pinwheel, with different parts rotating at different speeds. This observation was crucial in understanding the dynamics of the galaxy and continues to be a topic of study today. Did you know that astronomers now believe the Milky Way has more than just the main spiral arms? There are also numerous smaller, fainter arms and spurs that branch off in various directions. These structures add another layer of complexity to our understanding of the galaxy, illustrating that it is not just a simple symmetrical spiral, but a dynamic and evolving system. Here's something curious about those spiral arms. Scientists discovered that they are not permanent structures. Instead, they are regions of higher density that move through the galaxy like cosmic traffic jams. As stars pass through these arms, the increased density can trigger star formation, leading to the creation of new stars, planets, and potentially even life. The more you learn about these discoveries, the more you appreciate the intricate dance of stars and matter that makes up the Milky Way. Speaking of which, did you know that the center of our galaxy is home to some of the densest star clusters known? These clusters, such as the Archer's cluster, contain some of the most massive stars in the galaxy and provide unique laboratories for studying star formation and evolution. This brings us to another fascinating find. Stars in the Milky Way's bulge, the dense region around its core, are significantly older than those in the spiral arms. This age disparity offers clues about the history and evolution of our galaxy, suggesting a complex formation process where different regions developed at different times. To put this in perspective, the Milky Way's journey from ancient myth to modern understanding showcases the enduring human quest to comprehend the cosmos. From early philosophical ideas to groundbreaking technological advances, each discovery has revealed a new layer of complexity, deepening our appreciation for the galaxy that is our home. As we continue to explore the vastness of the Milky Way, we are reminded of the endless possibilities that lie beyond, waiting to be uncovered. One curious detail about our galaxy is that the Milky Way is not alone in its cosmic neighborhood. It turns out that we are part of a group known as the Local Group, which consists of more than 50 galaxies. Our galactic companions include notable members like the Andromeda Galaxy and a smaller galaxy called the Triangulum Galaxy. This gathering of galaxies is bound together by gravity, and in some ways, they share a collective journey through the universe. Interestingly, within this local group, the Milky Way is on a collision course with the Andromeda Galaxy. Scientists predict that in about 4 billion years, these two spiral galaxies will merge to form a new, larger galaxy. For now, they are separated by a staggering 2.5 million light-years, yet they are steadily moving closer at a pace of about 110 kilometers per second. This cosmic dance offers a fascinating glimpse into the future of our galaxy. Here's something unexpected. The Milky Way is not a perfect spiral. It has a slightly warped disk, which astronomers believe is caused by interactions with nearby galaxies and dark matter. This warp gives the galaxy a gentle twist, illustrating the dynamic and ever-evolving nature of our cosmic home. It's a beautiful reminder of the interconnected forces at play in the universe. Have you ever wondered about the quiet and dark regions of the Milky Way? These are known as dark nebulae, and they are regions dense with gas and dust that block the light from stars behind them. One of the most famous is the Coal Sack Nebula, which is visible to the naked eye in the southern hemisphere. These dark patches are not merely voids, they are rich in the raw materials needed for star formation, serving as cosmic cradles for new celestial bodies. Another intriguing fact is that the Milky Way holds a small but powerful cluster of stars called globular clusters. These clusters are tightly packed groups of stars orbiting the galaxy's core. They are among the oldest objects in our galaxy, providing scientists with clues about its early history and formation. The study of these clusters helps us understand the conditions of the early universe, offering a window into the past. Did you know that the Milky Way has a halo of old stars surrounding its core? This halo extends far beyond the visible spiral arms and contains some of the oldest stars in the galaxy. These stars are thought to be remnants of ancient galaxies that merged with the Milky Way long ago. The halo's presence is a testament to the galaxy's turbulent history, marked by countless mergers and interactions over billions of years. Speaking of ancient stars, let's consider the fascinating concept of stellar archaeology. This field involves studying the chemical composition of stars to uncover the history of the Milky Way. By analyzing the elements found in stars, astronomers can piece together stories about past galactic collisions and events. It's like being a detective, unraveling the mysteries encoded in the light of distant suns. Here's a curious fact about our galaxy's inhabitants. The Milky Way is home to rogue planets. These planets do not orbit a star and instead wander through space, possibly ejected from their original solar systems. Their existence challenges our understanding of planetary formation and migration, offering tantalizing hints about the diversity of planetary systems in the universe. It turns out that the Milky Way has a unique feature called the Sagittarius Stream. This is a stream of stars and other material that stretches across the sky, a remnant of a smaller galaxy being absorbed by the Milky Way. The stream's discovery provided evidence of the galaxy's cannibalistic nature, showing how it grows by consuming smaller galaxies. This process is a stark reminder of the ongoing and dynamic nature of galactic evolution. Interestingly, scientists have discovered that the Milky Way's center is teeming with molecular clouds. These clouds are rich in complex organic molecules, including some that are the building blocks of life as we know it. This chemical complexity in the galactic core raises intriguing questions about the potential for life elsewhere in the galaxy and the processes that lead to its emergence. Consider this. The Milky Way's core contains a mysterious population of stars known as blue stragglers. These stars appear younger and hotter than their surrounding neighbors, which is puzzling given their location in an area filled with ancient stars. One explanation is that they result from collisions or mergers between stars, creating a rejuvenated, youthful appearance. The existence of these stars challenges our understanding of stellar evolution and the dynamics within dense star clusters. Here's something particularly fascinating. The Milky Way's disk contains a substantial amount of interstellar dust. This dust, although seemingly insignificant, plays a critical role in the galaxy's life cycle. It contributes to star formation and acts as a shield protecting nascent stars from harsh radiation. The interplay between stars and dust is an intricate ballet that sustains the galaxy's ongoing evolution. Lastly, one of the more enchanting aspects of our galaxy is the Milky Way's magnetic field. Though invisible, it weaves throughout the galaxy, influencing the motion of charged particles and shaping the patterns of gas and dust. This invisible force adds another layer of complexity to the galaxy's structure, reminding us of the unseen threads that connect and bind the cosmos. Each of these discoveries deepens our appreciation for the Milky Way, revealing it as a living, breathing entity filled with surprises and mysteries. As you drift into a state of wonder, Remember that our galaxy is not just a backdrop for the night sky, but a vibrant and dynamic system teeming with stories waiting to be unearthed. The more we learn, the more we realize how much there is yet to discover, continuing to inspire a sense of curiosity and awe. It turns out that the Milky Way is a galaxy with many surprises, one of which involves its so-called thick disk. This feature is sandwiched between the galaxy's thin disk, where most of the visible stars reside, and the halo. The thick disk is home to older stars and contains about 10 to 20% of the galaxy's total stellar mass. This lesser-known structure provides astronomers with clues about the early days of our galaxy's formation, offering insights into the Milky Way's turbulent youth when it was bombarded by smaller galaxies. Here's something unexpected. The Milky Way is not just a spiral galaxy, but also exhibits features of a barred spiral galaxy. Bars are dynamic structures composed of stars that cut through the center of some spiral galaxies, including ours. These bars are believed to act as stellar highways, funneling gas from the outer regions towards the core, fueling star formation and possibly feeding the central supermassive black hole, Sagittarius A star. This mechanism plays a critical role in the evolution and dynamics of the galaxy. Interestingly, while the Milky Way is incredibly vast, spanning 100,000 light-years, it is not the largest galaxy in our neighborhood. That title goes to the Andromeda Galaxy, which is about 220,000 light-years across. Despite this size difference, both galaxies are on a collision course, destined to merge in billions of years, creating a new galactic entity. This cosmic dance of such colossal structures reminds us of the universe's ever-changing nature. Consider this. The Milky Way has a unique attribute known as the galactic fountain. This phenomenon occurs when supernovae and stellar winds push gas out of the galaxy's disk. Eventually, gravity pulls this gas back down, creating a cycle similar to a fountain. This circulation of material not only redistributes elements within the galaxy, but also plays a part in regulating star formation rates. One curious detail about our galaxy involves its rotation curve. Contrary to the expectations set by visible matter alone, the Milky Way's outer regions rotate at similar speeds to its inner parts. This anomaly is one of the key pieces of evidence suggesting the presence of dark matter, a mysterious substance that exerts gravitational forces but does not emit light. The investigation of these rotation curves continues to be a cornerstone of astrophysical research, connecting our galaxy to the broader puzzle of dark matter. Here's something to ponder. The Milky Way's star formation rate is relatively modest compared to other galaxies. It forms about 1 or 2 solar masses of stars per year. This steady pace has profound implications for the galaxy's longevity and stability, suggesting a balanced cosmic environment that allows stars and planetary systems to develop over extended periods. Did you know that the Milky Way is home to a peculiar feature known as the galactic habitable zone? This concept outlines a region where conditions might be just right for life as we know it, similar to the habitable zone around stars that may support life-bearing planets. Factors like metallicity, radiation levels, and the likelihood of catastrophic events play into determining this zone. Scientists believe that understanding this region can guide the search for extraterrestrial life within our own galaxy. Another fascinating aspect of the Milky Way is its complex chemical diversity. The stars in different regions of the galaxy display varying abundances of elements. This variation is due to the diverse history of star formation and the accretion of smaller galaxies that have enriched the Milky Way over time. Studying these chemical signatures helps astronomers map the galaxy's evolutionary path, painting a detailed picture of its past interactions and mergers. Let me share something intriguing. The Milky Way contains a population of hypervelocity stars. These stars move at such extreme velocities that they can escape the galaxy's gravitational pull. They are typically believed to be ejected from the vicinity of the supermassive black hole at the galaxy's center, often as a result of complex gravitational interactions. These celestial speedsters offer valuable information about the forces and dynamics at play within the galaxy. Consider the Milky Way's intermediate mass black holes, a less discussed component of our cosmic home. These elusive objects are smaller than the supermassive black hole at the center, but larger than typical stellar black holes. Their existence provides a missing link in our understanding of black hole formation and evolution. Although difficult to detect, they are thought to reside in dense star clusters or around the galaxy's central region. Here's something that might surprise you. The Milky Way is surrounded by a significant amount of ionized gas, which extends far beyond the visible boundary of the galaxy. This circumgalactic medium is believed to play a crucial role in galactic evolution by regulating the inflow and outflow of gas. It acts as a reservoir for future star formation, linking the galaxy to its larger cosmic environment. Interestingly, the Milky Way's magnetic field is not uniform. It varies in strength and direction, influenced by the galaxy's rotation and the distribution of interstellar matter. This magnetic landscape affects everything, from the formation of stars to the propagation of cosmic rays, revealing another layer of complexity in our understanding of the galaxy. Lastly, let me tell you about the fascinating phenomenon of galactic cannibalism in the Milky Way. Throughout its history, our galaxy has absorbed many smaller galaxies. This process not only increases the Milky Way's mass, but also contributes to its stellar and chemical diversity. The remnants of these devoured galaxies can still be observed today in the form of star streams and distinct stellar populations, providing a glimpse into the galaxy's dynamic and tumultuous past. Each of these hidden connections within the Milky Way demonstrates the complexity and beauty of our galactic home. They remind us of the intricate web of interactions that have shaped the galaxy over billions of years, painting a picture of a universe rich with history and yet full of mysteries waiting to be uncovered. As you continue to explore these celestial wonders, let your imagination soar across the vast expanse of the Milky Way, where every star and every element tells a story of cosmic evolution and discovery. In the heart of the Milky Way, there's an astonishing celestial feature known as the Peacock Star Cluster, or NGC 6878. Not only does it sparkle with a dazzling array of stars, but it also sits approximately 60,000 light-years away from Earth in the galaxy's dense core region. This cluster is particularly intriguing due to its composition of both young and older stars, offering a vivid snapshot of stellar evolution within our galaxy. Here's something unexpected. The Milky Way is home to the mysterious Smith Cloud. This massive cloud of hydrogen gas is on a collision course with our galaxy, expected to impact in about 30 million years. The Smith Cloud is moving at high speed, and its collision will likely trigger new star formation in the Milky Way's outer regions. This impending event highlights the dynamic nature of our galaxy's evolution and the ongoing interactions it has with intergalactic matter. Another fascinating aspect of the Milky Way is its hidden population of ultra-faint dwarf galaxies. These galaxies are some of the smallest and dimmest known, residing in the galactic halo. Despite their faintness, they are considered crucial for understanding dark matter distribution, as they appear to contain a high ratio of dark matter to visible matter. Their discovery provides key insights into the building blocks of larger galaxies like the Milky Way. Consider the peculiar astronomical phenomenon known as gamma-ray bursts, which are among the most energetic events in the universe. Interestingly, Some shorter gamma-ray bursts, detected by telescopes, are believed to have originated from the Milky Way itself. These bursts are often associated with the collision of neutron stars or the collapse of massive stars, and they serve as cosmic beacons, shedding light on the extreme processes occurring within our galaxy. Here's something curious. The Milky Way's Ophiuchus supernova, one of the closest supernovae to Earth recorded in historical times, occurred in the year 1066. This event was so bright that it was visible to the naked eye during the day for several weeks. Such supernovae are not only spectacular celestial events, but also contribute to the enrichment of the interstellar medium with elements necessary for the formation of planets and life. One of my favorite facts involves the strange and rare Thorn-Jaikow objects, a type of star theorized to exist within the Milky Way. These hybrid stars are thought to form when a red giant star consumes a neutron star, creating a unique setup where the neutron star sits at the center of the giant. While observational evidence is limited, these objects represent an extraordinary blend of stellar evolution and the extremes of astrophysical phenomena. Speaking of extraordinary, the Milky Way's inner Lindblad resonance is a gravitational feature that plays a crucial role in shaping the galaxy's spiral arms. This resonance occurs when the gravitational pull of the galaxy's bar aligns with the orbits of stars and gas clouds, creating a pattern that enhances and maintains the spiral structure. It's like a cosmic dance that keeps the Milky Way's arms gracefully swirling through the cosmos. Here's something unexpected. The Milky Way contains a peculiar star system known as WR 1422. This system includes a star that is among the hottest and most luminous known, a Wolf-Rayet star, which exhibits powerful stellar winds stripping away its outer layers. These winds enrich the surrounding space with heavy elements, contributing to the cycle of matter within the galaxy. Let me share a curious detail about the Fermi bubbles, enormous structures extending above and below the Milky Way's central region. These bubbles are filled with high-energy particles and gamma rays, believed to be the remnants of past energetic events, possibly linked to the activities of the central supermassive black hole. They serve as a testament to the dynamic and sometimes violent history of our galaxy's core. Interestingly, there's a feature known as the Monoceros Ring, a vast stellar structure wrapping around the Milky Way. This ring is thought to be the remnants of a dwarf galaxy that was torn apart and absorbed by our galaxy. The Monoceros Ring provides a fascinating glimpse into the galaxy's history of mergers and the intricate patterns left behind by these cosmic interactions. Here's something that might surprise you. The Milky Way is not only home to stars and planets, but also to rogue planets, which drift through space untethered to any star. These orphaned worlds likely formed in planetary systems before being ejected, and their presence challenges our understanding of planet formation and stability within the galaxy. One curious detail involves the Milky Way's halo, which contains an abundance of blue straggler stars. These stars appear younger and hotter than their companions in the halo, though their exact origin is still debated. One theory suggests that they form when two stars in a binary system merge, rejuvenating their appearance. Blue stragglers offer a unique window into the complex life cycles of stars in the galaxy's less dense outskirts. Speaking of stellar mysteries, the Milky Way also boasts Cepheid variables, a class of stars used as cosmic yardsticks. These stars pulsate at regular intervals, and their brightness variations correlate with their intrinsic luminosity, allowing astronomers to measure distances to far-off regions of our galaxy and beyond. The study of Cepheid variables has been instrumental in mapping the structure of the Milky Way and refining our understanding of the universe's scale. Lastly, let me introduce you to the Magellanic Stream, a vast ribbon of hydrogen gas that stretches from the Milky Way to its satellite galaxies, the Magellanic Clouds. This stream is the result of gravitational interactions and tidal forces between the galaxies, and it plays a crucial role in the exchange of matter between them. The Magellanic Stream is a vivid reminder of the interconnectedness of galaxies and the dynamic processes that continue to shape our cosmic neighborhood. As the Milky Way reveals its wonders, these hidden features and phenomena illustrate the galaxy's complexity and its continuous journey through time and space. From the tiniest faint galaxies to powerful gamma-ray bursts, each element contributes to the grand tapestry of our cosmic home, inviting us to explore, question, and learn from the celestial stories written among the stars. It turns out that the Milky Way is not just a serene band of stars across the night sky, but a bustling metropolis of celestial activity. One curious detail is the presence of the galactic habitable zone, an intriguing concept in astrophysics. This zone is a region where conditions are thought to be just right for the development of life, much like the habitable zone around a star. However, this galactic version is based on a balance of factors such as metallicity, radiation levels, and distance from supernovae, all of which contribute to the potential for life-supporting planets to form and thrive. Interestingly, the Milky Way is home to a curious class of stars known as hypervelocity stars. These stars are traveling at such immense speeds that they can escape the gravitational pull of the galaxy. It's thought they achieve such velocities following close encounters with the supermassive black hole at the galaxy's center, or through interactions with other stars in binary systems. This rare phenomenon turns these stars into cosmic travelers, journeying through the vastness of intergalactic space. Consider this. Embedded within the Milky Way's structure are structures known as chimneys. These are large vertical channels of hot gas that extend from the disk into the halo of the galaxy. They act as conduits for energy and matter, allowing supernova ejecta and stellar winds to escape into the galactic halo. Such structures are vital for the recycling of materials and play a significant role in the evolution of the galaxy. Here's something unexpected. The Milky Way contains regions known as stellar streams, which are elongated bands of stars that have been pulled from satellite galaxies. These streams are relics of past galactic interactions, where smaller galaxies have been stretched and torn apart by the Milky Way's gravity. The study of these streams provides insights into the galaxy's gravitational field and helps astronomers trace the Milky Way's history of cosmic mergers. Speaking of stellar streams, one fascinating aspect is the Helmi stream, a group of stars that were likely part of a dwarf galaxy absorbed by the Milky Way about 6 to 8 billion years ago. By studying the movement and composition of stars within this stream, scientists glean valuable clues about the galaxy's past interactions and how it has grown over time through the accumulation of smaller systems. Interestingly enough, the Milky Way's halo contains a peculiar group of stars known as carbon stars. These stars have an atmosphere rich in carbon rather than oxygen, giving them a distinctive red hue. The abundance of carbon can lead to the formation of molecules like carbon monoxide and even complex organic compounds in the surrounding space, hinting at the potential chemical diversity within the galaxy's outer reaches. One of my favorite facts is the presence of microlensing events in the Milky Way. These events occur when a massive object, like a star or planet, passes in front of a distant star, bending and focusing its light like a lens. This phenomenon allows astronomers to detect otherwise invisible objects, such as planets or dark matter candidates, making it a powerful tool for uncovering hidden components of our galaxy. Here's something curious. The Milky Way's central bulge is not symmetrical, but exhibits a peanut-like shape. This distinctive structure likely resulted from the gravitational interactions and resonances within the galaxy's bar. Such unique formations provide astronomers with essential clues about the dynamic processes shaping the inner regions of the Milky Way. One surprising aspect of our galaxy involves the galactic plane, a flat region where most of the Milky Way's stars and matter are concentrated. The plane is tilted relative to our solar system's orbit, leading to a unique alignment that allows us to observe different parts of the galaxy as Earth orbits the Sun. This perspective offers a constantly shifting view of the Milky Way's diverse regions and features. Did you know that the Milky Way contains a mysterious feature known as the Great Rift? This dark band of dust and gas obscures the light from stars behind it, creating a striking divide in the visible galaxy. The Great Rift is an essential region for star formation, as its dense clouds are stellar nurseries where new stars are born from the material accumulated over eons. Here's a fascinating fact. Certain regions within the Milky Way serve as galactic laboratories for studying extreme astrophysical processes. For instance, the Crab Nebula, a supernova remnant located within the galaxy's Perseus arm, is an object of intense study. The nebula is a source of high-energy radiation and cosmic rays, offering insights into the life cycles of massive stars and the mechanisms of supernova explosions. One curious phenomenon involves the galactic warp, a bending of the Milky Way's disk that causes it to appear twisted, like a warped vinyl record. This distortion is likely caused by interactions with nearby galaxies or the influence of dark matter, and it offers astronomers a dynamic view of the gravitational forces at play in shaping the galaxy's structure. Interestingly, the Milky Way contains a unique population of RR Lyrae stars, which are pulsating variables used as standard candles to measure distances within the galaxy. These stars provide crucial data for mapping the galaxy's structure and understanding the distribution of its mass, contributing to a more detailed picture of the Milky Way's vast expanse. Lastly, consider the intriguing galactic center radio arc, a massive filamentary structure near the Milky Way's core. This radio-emitting feature is aligned with the galaxy's magnetic field and spans hundreds of light-years. Its precise nature is still under investigation, but it serves as a remarkable testament to the complex and dynamic environment at the heart of our galaxy. From hypervelocity stars to cosmic chimneys, these astonishing facts highlight the Milky Way's vibrant and ever-changing nature. Each discovery adds a piece to the intricate puzzle of our galaxy, encouraging us to look deeper into the cosmos and seek answers to the mysteries that unfold among the stars. As we continue to unravel these secrets, the story of the Milky Way becomes not just a tale of stars and planets, but a narrative of cosmic evolution interwoven with the fabric of the universe itself. Scientists have discovered that the Milky Way is surrounded by a halo of stars that extends far beyond its visible disk. This halo is composed of stars that are much older than those found in the galaxy's spiral arms. Some of these stars are thought to be remnants of ancient mergers with smaller galaxies, providing a glimpse into the Milky Way's formative years. The halo's existence hints at a history full of cosmic interactions and mergers, painting a picture of a galaxy built from countless smaller systems. Here's something unexpected. The Milky Way's halo is home to a rare type of star, known as a blue horizontal branch star. Unlike most stars, which burn hydrogen in their cores, these stars are in a later stage of their life cycle, burning helium instead. They shine with a distinct blue hue, adding a touch of color to the galaxy's otherwise dim halo. These stars serve as important markers for astronomers mapping the halo's structure and understanding its stellar population. Consider this. The Milky Way has a mysterious region known as the galactic corona. This hot, diffuse gas envelope surrounds the galaxy and is much hotter than the disk itself. Although its presence is not directly visible, the corona can be detected through the X-rays it emits. It plays a crucial role in regulating the galaxy's temperature and influences the way the Milky Way interacts with its environment. The corona's properties are still being explored, leaving many intriguing questions about its nature and origin. In an interesting twist, scientists have found that the Milky Way contains a small number of hypervelocity stars. These stars move at such incredible speeds that they can escape the galaxy's gravitational pull entirely. Their high velocities suggest that they may have been ejected from the galactic center after interactions with the supermassive black hole, Sagittarius A. These stars provide insights into the dynamics of the galaxy's core and the powerful forces at play there. Interestingly, the Milky Way is not a static structure, but a dynamic and evolving entity. One aspect of this evolution is the presence of galactic cannibalism, where larger galaxies like the Milky Way absorb smaller ones. This process contributes to the growth and reshaping of the galaxy over time. Evidence of such events is visible in the form of faint stellar streams that trace the orbits of devoured galaxies, offering astronomers a window into the galaxy's complex history. One curious detail is that the Milky Way's disk contains ring-like structures that are shaped by tidal interactions with neighboring galaxies. These rings are not permanent features, but appear and dissolve over time due to the gravitational forces that mold the galaxy's shape. Observations of these rings help scientists understand the effects of galactic interactions and the role they play in shaping the spiral disk. A surprising aspect of our galaxy is the presence of magnetars, a type of neutron star with an immensely strong magnetic field. These magnetic fields are billions of times stronger than that of the Earth, and they can occasionally produce powerful bursts of X-rays and gamma rays. Magnetars are rare, with only a handful known in the Milky Way, but their existence reveals the extreme environments that can be found within our galaxy. Here's a fascinating fact. The Milky Way is home to regions known as starburst areas, where stars are forming at an exceptionally high rate. These areas are often located in the galaxy's spiral arms and are fueled by the dense clouds of gas and dust concentrated there. Starburst regions offer astronomers a chance to study the intense processes of stellar formation and the mechanisms that drive them. It turns out that the Milky Way contains a unique feature called the Sagittarius stream. This is a trail of stars that arcs around the galaxy and is the remnants of the Sagittarius dwarf galaxy, which has been torn apart by the Milky Way's gravitational forces. The stream offers astronomers a clear example of how smaller galaxies can be integrated into larger ones, and it continues to be an area of active research. One peculiar phenomenon involves the Milky Way's Fermi bubbles, enormous lobes of gas that extend above and below the galactic center. These bubbles are thought to have formed from past activity of the supermassive black hole at the galaxy's core, possibly involving massive jets of energy that blew the gas into space. The bubble's existence provides a glimpse into the past energetic events that have shaped the galaxy. Did you know that the Milky Way's outer regions host a population of extreme metal-poor stars? These stars contain very few elements heavier than helium, suggesting they formed in the early universe before many of the heavier elements were created in stars. Studying these stars helps astronomers piece together the chemical history of the galaxy and understand the conditions of the early universe. Another interesting finding is that the Milky Way's disk has flaring at its outer edges, where the thickness of the disk increases. This flaring is influenced by the galaxy's interaction with dark matter and the gravitational pull from nearby galaxies. It provides insights into the distribution of mass in the galaxy and the forces that have shaped its structure over time. Scientists have discovered a fascinating phenomenon known as galactic tidal tails, which are streams of stars and gas that stretch away from galaxies involved in a gravitational encounter. The Milky Way has its own tidal tails, remnants of past interactions with smaller galaxies. These tails are key to understanding the history of galactic mergers and the ongoing evolution of our galaxy. Lastly, consider the stellar halo, a component of the Milky Way that extends far beyond the visible disk and contains a diverse population of stars. This halo is thought to be a relic of the galaxy's early days and may hold clues to the processes that formed the galaxy. By studying the stellar halo, astronomers gain insights into the Milky Way's formation and the ancient events that shaped it. These surprising truths about the Milky Way reveal a galaxy that is far more complex and dynamic than it might appear at first glance. Every discovery deepens our understanding of the structure and history of our galactic home, encouraging us to explore the vast cosmos with renewed curiosity. As we unravel these mysteries, the Milky Way becomes a vibrant tapestry of stars, gas, and dust, woven together by the forces of the universe itself. Here's something unexpected. Within the Milky Way, there are stars known as carbon stars, which have atmospheres enriched with carbon rather than the more common hydrogen and helium. These stars burn with a striking reddish hue, different from the usual white or blue of other stars. Carbon stars are fascinating because they contribute to the chemical enrichment of the galaxy by shedding their outer layers, spreading elements that are vital to life across the cosmos. The unique color of these stars adds a splash of diversity to the galaxy's stellar population. Another lesser-known detail is the existence of massive dust lanes that thread through the Milky Way's spiral arms. These dark, dense regions are composed of tiny particles of dust and gas, which absorb and scatter light, creating striking dark streaks against the bright backdrop of the galaxy. Dust lanes are not only visually captivating but also play a crucial role in star formation, as they provide the raw materials needed to birth new stars. Consider this. The Milky Way has a peculiar feature called galactic warps. These are twists in the galaxy's disk, resembling ripples in a pond when viewed from afar. The warps are thought to be caused by gravitational interactions with neighboring galaxies or the influence of the dark matter halo surrounding the Milky Way. These ripples in the galaxy's structure are subtle yet significant in understanding how the galaxy interacts with its environment. Scientists discovered that the Milky Way is home to a family of stars called blue stragglers. These stars appear younger and hotter than their neighbors in the same stellar clusters, which is puzzling because they are thought to be as old as the cluster itself. Blue stragglers are believed to form through stellar collisions or mass transfer between stars in binary systems, making them an intriguing anomaly in the standard model of stellar evolution. It turns out that the Milky Way contains regions known as Lyman alpha blobs. These mysterious glowing clouds of hydrogen gas emit ultraviolet light and are believed to be associated with the formation of galaxies and stars in the early universe. The discovery of Lyman alpha blobs in our galaxy provides astronomers with a rare opportunity to study the processes that took place during the galaxy's infancy and offers clues about the conditions that led to the formation of the first stars. One curious detail about the Milky Way is the presence of OB associations, which are groups of young, massive stars that are loosely bound and will eventually disperse. These associations are named after the spectral types O and B, which represent the hottest and most massive stars. Studying OB associations helps astronomers understand the processes of massive star formation and the dynamics of young stellar populations within the galaxy. Interestingly, The Milky Way exhibits a phenomenon known as galactic drift, where stars slowly migrate over time due to gravitational interactions and the influence of the galaxy's spiral arms. This drift can result in stars moving to entirely different regions of the galaxy over millions of years. Understanding galactic drift provides insights into the long-term evolution of the Milky Way and the ways in which stars and stellar systems interact within it. Here's something that might surprise you. The Milky Way's central region is home to methanol masers, which are natural amplifiers of microwave radiation. These masers are found in regions of intense star formation and can provide valuable information about the physical conditions and dynamics of these energetic areas. Methanol masers serve as precise tools for mapping the galaxy's structure and understanding the complex processes occurring in its active regions. One remarkable discovery is the existence of stellar bow shocks within the Milky Way. These are formed when fast-moving stars plow through the interstellar medium, creating a shock wave similar to the bow of a ship cutting through water. Stellar bow shocks can offer clues about the speed and direction of stellar motion and help astronomers gain a deeper understanding of the interactions between stars and their surrounding environments. Consider the Milky Way's galactic habitable zone, a region where conditions may be suitable for life to develop on orbiting planets. This zone is determined by factors such as the density of stars, the presence of heavy elements, and the stability of orbits. Studying the galactic habitable zone allows scientists to identify potential areas where life might exist beyond Earth, expanding our understanding of habitability in the universe. Did you know that the Milky Way has a galactic fountain, where gas heated by supernovae and stellar winds is ejected out of the galactic disk into the halo? This gas eventually cools and falls back into the disk, contributing to a cycle of matter that fuels ongoing star formation. The galactic fountain highlights the dynamic processes that recycle and redistribute material within the galaxy, fostering an environment conducive to the formation of new stars and planets. Here's a fascinating aspect of the Milky Way. It hosts gamma-ray halos, which are diffuse emissions of gamma rays surrounding the galaxy. These halos are thought to be produced by interactions between cosmic rays and interstellar matter, shedding light on the high-energy processes occurring throughout the galaxy. Understanding gamma-ray halos can reveal insights into the sources and propagation of cosmic rays, as well as the role of magnetic fields in the galaxy. Lastly, ponder the Milky Way's galactic chimneys, which are vertical structures that allow gas and dust to escape from the disk into the halo. These chimneys are thought to be driven by the combined effects of supernova explosions and stellar winds, acting as conduits that channel material away from the dense star-forming regions. Galactic chimneys play a crucial role in regulating the gas content and star formation activity in the galaxy, illustrating the interconnected nature of its various components. Reflecting on these intriguing aspects of the Milky Way, we find a galaxy that is not only a collection of stars and planets, but a complex and ever-changing entity, shaped by the forces of the universe. Each fact unveils another layer of the Milky Way's story, offering a glimpse into the intricate tapestry of processes that govern our galactic home. The more we learn, the more we appreciate the beauty and mystery of the cosmos, prompting us to continue exploring and seeking answers among the stars. Speaking of mysteries, the Milky Way's vast expanse holds more than just stars and planets. Let's delve into the concept of galactic archaeology. This fascinating field of study seeks to unravel the history of our galaxy by examining the properties and motions of stars, much like how archaeologists on Earth uncover the past by examining soil layers and artifacts. Galactic archaeologists study the fossil records left behind by ancient stars. They analyze the chemical compositions and trajectories of stars to piece together the sequence of events that shaped the Milky Way over billions of years. Consider the discovery of ancient stellar populations within the Milky Way's halo. These stars, found on the outskirts of the galaxy, provide crucial clues about the Milky Way's formative years. By studying their chemical signatures, scientists have found evidence suggesting these stars originated from smaller galaxies that merged into the Milky Way. This process of galactic mergers is thought to have been a driving force behind the growth and structure of our galaxy. One could say, in a sense, that the Milky Way has a history of cosmic assimilation, continually evolving by adding pieces of other galaxies to its grandeur. The richness of this galactic history also manifests in the stellar archaeology techniques used to track the chemical evolution of the galaxy. Stars act as time capsules, preserving elements forged in their cores over millions of years. As these stars go through their life cycles, they release these elements into the interstellar medium upon their demise, contributing to the chemical enrichment of the galaxy. For instance, the presence of elements heavier than helium, often referred to as metals in astronomical terms, provides insights into the past supernovae that enriched the galactic environment. These metals are key to understanding the processes that lead to the formation of new stars and planets, painting a continuous picture of the galaxy's evolution. Now let's shift our gaze to the concept of galactic archaeology in practice. One tool that has propelled this field forward is the study of stellar streams. These are elongated trails of stars that extend across the sky, remnants of dwarf galaxies and star clusters that have been disrupted and stretched out by the gravitational pull of the Milky Way. By mapping these streams and understanding their origins, astronomers can trace back the galaxy's accretion history and uncover details about the dark matter that governs the Milky Way's gravitational landscape. Yet, the Milky Way is not just a relic of the past. It is a dynamic system, continually engaging in a cosmic dance with its surroundings. An intriguing aspect of this dance is the role of hot Jupiters. These are gas giant exoplanets that orbit very close to their stars, often completing an orbit in just a few days. Although not native to our solar system, the presence of hot Jupiters in the Milky Way offers a window into planetary migration and formation theories. The prevailing thought is that hot Jupiters form further out in their star systems and migrate inward over time. This inward movement can have profound effects on the potential habitability of other planets in the system, as their gravitational interactions can lead to significant orbital rearrangements. Turning our attention to another cosmic feature, we explore the intriguing phenomenon of galactic winds. These powerful outflows of gas are driven by intense star formation and supernova explosions, capable of expelling material into intergalactic space. Galactic winds play a significant role in shaping the evolution of galaxies by regulating the rate of star formation. They can halt star formation by blowing out the gas needed to form new stars, or trigger it by compressing gas in other regions. The Milky Way is a prime laboratory for studying these processes, as its active star-forming regions generate such winds that influence the surrounding galactic environment. In the realm of cosmic phenomena, the Milky Way also hosts galactic fountains. These occur when hot gas, expelled by supernovae and stellar winds, rises into the galactic halo, cools and eventually falls back into the disk. This recycling of material contributes to the ongoing cycle of star formation and chemical enrichment, highlighting the interconnected processes that sustain the galaxy's vitality. The idea that the Milky Way is in constant flux, with matter cycling in and out of different galactic components, underscores the dynamic and ever-evolving nature of our galaxy. One might wonder how these processes impact the broader context of the universe. Consider the concept of cosmic star formation history, a timeline that charts the rate of star formation throughout cosmic history. The Milky Way, being an average-sized spiral galaxy, serves as a representative model for understanding star formation trends across the universe. By studying how star formation rates have changed over time in the Milky Way, astronomers gain insights into the life cycles of galaxies and the factors that influence their growth and transformation. Speaking of transformation, let's not forget the role of supermassive black holes in galactic evolution. Sagittarius A, the supermassive black hole at the heart of the Milky Way, is a key player in the dynamics of the galaxy's central region. Its immense gravitational pull influences the orbits of stars near the core, and its activity can affect the distribution of gas and dust. Interestingly, the energy output of supermassive black holes, although not as prominent in our relatively quiet galaxy, can drive processes such as galactic winds and regulate star formation on a grand scale in more active galaxies. The interplay between a galaxy's bulge, its supermassive black hole, and surrounding star-forming regions is a subject of intense study, as it holds clues to the co-evolution of galaxies and their central black holes. Stepping back, we find ourselves contemplating the broader cosmic canvas. The Milky Way, a single galaxy among billions, is both a participant and an observer in the grand story of the universe. Its interactions with neighboring galaxies, the steady churning of stars and planets within its arms, and the invisible forces at play render it a microcosm of cosmic processes. This realization paints a picture of a galaxy that is not static, but one that resonates with the echoes of its past and the whispers of its future. Each star, each molecule of gas, and each grain of dust contributes to the ongoing narrative of our galaxy. As we continue to explore and understand these elements, we unravel a story that speaks to the interconnectedness of all things. From the smallest particles to the largest structures, the Milky Way embodies the beauty and complexity of the cosmos, inviting us to reflect on our place within this vast universe. In this gentle exploration, we've touched upon the intricate dance of galactic archaeology, the enigmatic processes driving stellar and planetary formation, and the awe-inspiring forces that shape our galaxy. Each fact reveals the Milky Way as a vibrant and living entity, a testament to the wonders of the cosmos and our endless quest for understanding. The Milky Way, a majestic spiral of cosmic wonder, has long captivated human curiosity. Its intricate dance of stars, planets, and cosmic phenomena narrates a tale as old as time itself, and there is a deep history woven into its very fabric. Let me share something fascinating about the historical journey that has brought us closer to understanding our galaxy. The journey began over 2 millennia ago with the Greek philosopher Democritus. He speculated that the Milky Way was nothing more than a distant collection of stars. This idea, though not immediately embraced, laid the groundwork for future astronomical discoveries. It was the keen observations and evolving theories of these early thinkers that slowly peeled away the layers of mystery surrounding the galaxy. Fast forward to the Renaissance, a period that ignited a new era of celestial exploration. The invention of the telescope revolutionized our perception of the universe. Galileo Galilei, known for his pioneering use of this tool, was able to see that the Milky Way was composed of myriad individual stars. This revelation shifted the understanding of the galaxy from a celestial mystery to a tangible collection of stars, each a sun in its own right. It was a profound realization that underscored the vastness and complexity of the universe. As centuries progressed, astronomers continued to map the night sky, each discovery building upon the last. In the 18th century, The meticulous cataloguing of celestial objects by William Herschel provided further insights into the structure of the Milky Way. Herschel's observations suggested a disc-like shape, which was a significant stride in visualizing the galaxy's form. But as we continued to gaze into the vastness, another aspect of the Milky Way began to reveal itself: the dynamic nature of its stars and the enormous cosmic forces at play. One of my favorite facts about the Milky Way is its rotational nature. Did you know that our galaxy spins like a giant cosmic whirlpool? This rotation is not uniform. Stars closer to the center move faster than those on the outskirts. This differential rotation is partly responsible for the spiral arms that define the galaxy's structure, giving it a graceful swirling pattern. Imagine the galaxy as a grand celestial ballet, with each star playing its part in a dance choreographed by gravity. Speaking of gravity, it's fascinating to delve into how this fundamental force sculpts the galaxy. The Milky Way's spiral arms are not just random assortments of stars, but are shaped by a process known as density wave theory. In this theory, the spiral arms are seen as regions of higher density that move through the galactic disk, similar to traffic jams on a highway. As stars and gas clouds enter these regions, they slow down, creating a temporary buildup that gives the arms their distinct appearance. This theory helps explain why the arms maintain their structure over billions of years, despite the constant movement of stars and gas. To put this in perspective, picture the Milky Way as a grand cosmic river, where stars are like water molecules, each following its unique path but collectively forming a beautiful and coherent flow. This image captures the essence of the galaxy's dynamic equilibrium, a balance that sustains its structure amidst the tumult of cosmic forces. The history of our understanding of the Milky Way is also marked by the discovery of its vast magnetic field. This invisible yet powerful force influences the motion of charged particles within the galaxy. Scientists have discovered that the Milky Way's magnetic field is structured into a spiral, mirroring the galaxy's physical form. These magnetic fields play a crucial role in star formation, guiding cosmic rays and affecting the interstellar medium. The interplay between magnetic fields and cosmic rays adds another layer of complexity to the galaxy's evolution, illustrating how unseen forces can have tangible effects on cosmic scales. Interestingly, the magnetic field also interacts with the galaxy's gas and dust, shaping the intricate patterns we observe in the interstellar medium. These interactions can trigger new star formation by compressing gas clouds, demonstrating the intricate connections between various cosmic processes. The more you learn about these cosmic interactions, the more you appreciate the delicate balance that sustains the galaxy's vitality. This reminds me of the concept of galactic ecology. Much like ecosystems on Earth, galaxies are a complex web of interactions between various components. Stars, gas, dust, and dark matter all play their parts in maintaining the galaxy's structure and driving its evolution. The flow of matter, energy, and information through the galaxy forms a cosmic network that is both resilient and adaptable. This network ensures that despite the constant change, the Milky Way retains its majestic spiral form. Considering these cosmic interactions, it's intriguing to think about the role of supernovae in the Milky Way's ecology. These explosive events are not just dramatic finales to stellar life stories, but are also key players in distributing heavy elements throughout the galaxy. The elements ejected by supernovae enrich the interstellar medium, providing the raw materials for new generations of stars and planets. This process of chemical enrichment is a vital aspect of the galaxy's life cycle, contributing to the diversity of stars and planetary systems. The remnants of these stellar explosions, such as neutron stars and black holes, add yet another dimension to the galaxy's complexity. These remnants create gravitational waves that ripple through space-time, adding an unseen layer of influence to the galaxy's dynamics. The detection of these waves opens a new window into understanding the universe, allowing scientists to study cosmic events that were previously hidden from view. And here's something fascinating. The Milky Way is not just a passive observer in the universe. It actively interacts with its cosmic environment, drawing in gas from intergalactic space to fuel star formation. This accretion of matter helps maintain the galaxy's star-forming regions, ensuring the continued birth of new stars. At the same time, the Milky Way sends out material through processes like galactic winds, contributing to the exchange of matter between galaxies. This ongoing interchange highlights the interconnected nature of galaxies, each shaping and being shaped by their surroundings. Reflecting on these processes, we can see the Milky Way as a living entity, constantly changing and adapting. Its history is a testament to the creativity of the universe, a cosmic story written in the language of stars and galaxies. Each discovery adds a new layer to our understanding, revealing the hidden tapestry of forces that govern the galaxy's evolution. As we explore these historical perspectives, it becomes clear that the Milky Way is not just a collection of stars and planets. It is a dynamic and interconnected system, a microcosm of the universe itself. Its ongoing story invites us to look beyond our immediate surroundings and consider our place within the vast expanse of the cosmos. In this gentle journey through the history of the Milky Way, we find echoes of our own quest for knowledge and understanding, a reflection of humanity's enduring curiosity and the boundless beauty of the universe. Continuing our exploration of the Milky Way, let's delve into the cultural connections that link us to this magnificent galaxy. Throughout human history, the Milky Way has been a source of inspiration, woven into the tapestry of myths and traditions across the world. For many cultures, this celestial river of stars has been a bridge between the earthly realm and the divine, a testament to its profound influence on human thought and spirituality. Consider the ancient Greeks, who saw the Milky Way as a spilt stream of milk from the goddess Hera, hence the term galaxius, from which we derive the word galaxy. This imagery highlights the intimate ties between celestial phenomena and mythology, where the cosmos becomes a stage for gods and mortals alike. The concept of the Milky Way as a divine path is not unique to the Greeks. In Hindu mythology, it is known as the Akash Ganga, akin to the Ganges River, linking the heavens with the sacred on earth. This association underscores the galaxy's significance as a cosmic connector, a bridge spanning the realms of the tangible and the ethereal. In the Americas, many indigenous cultures have their own interpretations. For the Navajo, the Milky Way is a marker that guides the spirits of the dead on their journey, a celestial path that ensures safe passage to the afterlife. The Cherokee, on the other hand, view it as a trail of cornmeal, a remnant from the time when spirits lived among humans. Such stories reflect the Milky Way's role as a guide and protector, providing comfort in the face of life's uncertainties. Moving to the other side of the globe, in China, the Milky Way is known as the Silver River. It features prominently in the tale of the Weaver Girl and the Cowherd, a story of love and separation that mirrors the movement of stars across the sky. Each year, during the Qixi festival, the stars Vega and Altair, representing the lovers, are said to reunite in the night sky, crossing the celestial river. This myth highlights how the Milky Way serves not only as a backdrop for human emotion, but also as a calendar, marking the passage of time and the cycles of nature. It's fascinating to think about how these myths and stories reveal the universal tendency to find meaning in the stars. They remind us that the Milky Way is more than just an astronomical object. It's a symbol of humanity's search for understanding and belonging in the cosmos. The tales associated with the Milky Way illustrate a deep-seated connection to the universe, where each culture weaves its own narrative into the celestial fabric. Speaking of cultural connections, the Milky Way has also inspired countless works of art, literature, and music. The ethereal quality of its light has captured the imagination of artists such as Vincent van Gogh, whose iconic painting Starry Night evokes the swirling patterns reminiscent of the galaxy's spiral arms. This artistic portrayal invites viewers to see the night sky not just as a scientific phenomenon, but as a source of beauty and reflection. In literature, the Milky Way has been a source of metaphor and muse. Poets and writers have long used its imagery to convey themes of infinity, mystery, and the passage of time. The galaxy often serves as a symbol of the unknown, inviting readers to ponder their place within the universe. For musicians, the Milky Way's rhythmic dance across the sky has inspired melodies that capture the serenity and grandeur of our cosmic home. In recent years, the field of astrotourism has emerged, offering people the opportunity to experience the Milky Way's splendor firsthand. Dark sky parks, where light pollution is minimized, provide perfect venues for stargazing. These initiatives not only allow people to appreciate the galaxy's beauty, but also raise awareness about the importance of preserving our night skies. As you gaze up at the Milky Way on a clear night, you become part of a legacy of skywatchers, connected through time by a shared wonder of the stars. Another intriguing angle to consider is how the Milky Way has influenced scientific thought and exploration. The drive to understand its structure and composition has led to groundbreaking discoveries in astronomy. The quest to map the galaxy has pushed the boundaries of technology, leading to innovations like powerful telescopes and space missions dedicated to charting the stars. Through these efforts, we have gained insights into the galaxy's spiral arms, star-forming regions, and the mysterious dark matter that holds it together. These scientific pursuits also highlight the collaborative nature of astronomy, where researchers from around the world unite in their efforts to unlock the secrets of the Milky Way. This shared endeavor underscores the idea that the galaxy belongs to all of humanity, a common heritage that transcends borders and unites us in our pursuit of knowledge. In reflecting on these cultural and scientific connections, it's clear that the Milky Way is not just a distant collection of stars. It is an integral part of our human experience, shaping our myths, inspiring our creativity, and driving our curiosity. Each story, each discovery, adds a new layer to our understanding, weaving us more deeply into the cosmic narrative. This rich tapestry of connections invites us to look beyond the confines of our immediate surroundings and consider the broader universe in which we live. The Milky Way serves as a reminder of the vast possibilities that exist beyond our planet, encouraging us to embrace the unknown and explore the mysteries that await. With each gaze into the night sky, we are reminded of our place in this grand cosmic story, a journey that continues to inspire wonder and discovery. The future of our exploration of the Milky Way holds thrilling possibilities that extend the boundaries of our cosmic understanding. One such avenue is the endeavor to capture an external perspective of our galaxy. Imagine the profound impact of seeing the Milky Way from the outside, a vantage point that could illuminate our place within the universe in new ways. Proposed missions aim to send probes beyond the edges of our galaxy to achieve such a view. This ambitious goal requires overcoming significant technological challenges, yet the prospect of capturing an image of the Milky Way from afar is tantalizing. Such a view would offer insights into the galaxy's overall structure, revealing its spiral arms in their entirety, and helping to answer questions about the distribution of stars and interstellar material. It is a task that underscores the spirit of human curiosity and the drive to expand our knowledge beyond the immediate confines of our cosmic neighborhood. In addition to the pursuit of an external snapshot, the search for extraterrestrial life remains a compelling frontier in our exploration of the Milky Way. The galaxy is replete with stars that host planetary systems, many of which lie within the so-called habitable zones where conditions might support life as we know it. This quest involves scanning the skies for signals that might indicate the presence of intelligent life forms, a task that captures the imagination and spirit of discovery. The hope of finding life elsewhere compels scientists to continually refine their methods, utilizing advanced technologies and ever more sensitive instruments. This endeavor is not merely a scientific pursuit, but also a philosophical one, prompting us to ponder our own existence in the context of a potentially life-filled universe. It encourages us to consider what it means to be part of a cosmos that might be teeming with other sentient beings, each with their own stories and histories. The technological advancements that underpin these explorations are themselves a testament to human ingenuity. Consider the potential for one day visiting or even inhabiting other parts of the Milky Way. While this may seem like the realm of science fiction now, the idea fuels innovation in propulsion technology and habitat design. The concept of interstellar travel challenges us to rethink our current limitations and explore new realms of possibility. Imagine a future where humanity has established colonies in distant star systems, each adapted to the unique conditions of its host environment. Such expansions would represent a significant leap in our evolution as a species, transforming us from a planet-bound civilization to one that roams the galaxy. This vision encourages us to cultivate the technologies that might one day allow us to navigate the vast distances between stars and to create sustainable living conditions in the harsh environments of space. As we dream of the future, we must also consider the ethical dimensions of our cosmic exploration. What responsibilities do we hold as we venture beyond our solar system? The discovery of extraterrestrial life, for instance, would necessitate a re-evaluation of our interactions with other forms of life. Should we encounter intelligent beings, how would we communicate, and what cultural exchanges might unfold? These questions invite us to reflect on our role as stewards of Earth and potential ambassadors to the stars. They urge us to approach the cosmos with humility and respect, acknowledging the interconnectedness of all life within the galaxy and beyond. As our reach extends into the Milky Way, the importance of preserving the integrity of both Earth and the environments we encounter cannot be overstated. This ethical framework is vital as we contemplate the expansion of human presence into the wider universe. The implications of future explorations are not limited to technology and ethics. They also encompass our understanding of the fundamental laws of physics. The Milky Way serves as a vast laboratory where theories can be tested and refined. For instance, the study of high-energy phenomena, such as the interactions between cosmic rays and magnetic fields, offers insights into the fundamental forces that govern the cosmos. These investigations push the boundaries of our knowledge, challenging existing models, and sometimes leading to groundbreaking discoveries. The Milky Way's diverse and dynamic environment allows scientists to observe celestial processes in real time, providing a richer understanding of the universe's underlying principles. The continual advancement of our scientific knowledge is a tribute to the collaborative nature of astronomical research, where scientists across the globe unite in their quest to decode the mysteries of the galaxy. These explorations also remind us of the delicate balance that exists within our galaxy. The Milky Way is a dynamic entity, constantly evolving as stars are born and die, as stellar systems drift through its spiral arms, and as gravitational forces shape its destiny. Recognizing this balance highlights the intricate dance of cosmic events that sustain and transform our galaxy. It encourages us to appreciate the fragile equilibrium that allows life to thrive on Earth, nestled safely within the protective embrace of the Milky Way. Understanding this balance can deepen our gratitude for the conditions that enable life and inspire efforts to preserve them for future generations. In contemplating these future endeavors, we are invited to engage with the philosophical implications of our explorations. The Milky Way challenges us to consider the vastness of the cosmos and our place within it. It beckons us to reflect on the nature of existence and the potential for life beyond our planet. This contemplation opens doors to new ways of thinking, encouraging us to broaden our perspectives and embrace the unknown. The exploration of the Milky Way is a journey not just through space, but also through the corridors of human thought and imagination. It prompts us to ask profound questions about purpose, destiny, and the role of humanity in the grand tapestry of the universe. As we look to the future, the Milky Way remains a source of wonder and inspiration. Its mysteries continue to captivate our imaginations, driving us to explore, learn, and grow. This journey is one of discovery and connection, weaving together the threads of science, philosophy, and creativity. The galaxy stands as a testament to the enduring spirit of exploration, a reminder of the infinite possibilities that await us in the vast expanse of the cosmos. Each step we take towards understanding the Milky Way brings us closer to answering the age-old questions about our origins, our existence, and our place in the universe. With every new discovery, we are reminded that we are part of a larger cosmic story, one that continues to unfold as we reach for the stars. Understanding our place in the vastness of the Milky Way also invites us to consider the profound connections between its components and how they contribute to the galaxy's complex tapestry. One intriguing aspect of the Milky Way is the role played by molecular clouds. These immense clumps of gas and dust, scattered throughout the galaxy, are the birthplaces of stars. Think of them as cosmic nurseries, where under the right conditions, gravity pulls the gas and dust together, initiating nuclear fusion and giving birth to new stars. This cyclical process of star formation and destruction enriches the interstellar medium with heavier elements, creating the building blocks for planets and potentially life. Scientists believe that understanding these molecular clouds could unlock secrets about the galaxy's evolution and its capacity to sustain life over billions of years. While much of the gas in these clouds is hydrogen, the most abundant element in the universe, the presence of complex organic molecules hints at the chemical diversity essential for life. These molecules, such as amino acids, are the precursors to more complex compounds that could eventually lead to the emergence of life. It is this chemical richness, born from countless stellar generations, that fuels our curiosity about the potential for life elsewhere in the galaxy. Moving beyond molecular clouds, the Milky Way is also home to numerous globular clusters, which are dense groups of ancient stars. These clusters orbit the galaxy's center in a halo and are among the oldest known structures, with some estimated to be over 12 billion years old. Holding hundreds of thousands of stars, globular clusters provide a glimpse into the early universe. The stars within these clusters are generally low in heavy elements, indicating they formed before the galaxy had undergone significant chemical enrichment. Their study offers insights into the conditions of the early galaxy and helps astronomers understand the timeline of cosmic events that shaped the Milky Way. One particularly fascinating feature of globular clusters is their stability. They are tightly bound by gravity, which allows them to exist for billions of years, surviving the dynamic and sometimes tumultuous environment of the galaxy. This stability makes them excellent laboratories for studying stellar evolution and dynamics. By observing these clusters, astronomers can test theories of star formation, interaction, and aging, making them an invaluable resource in the quest to understand our galaxy's history and development. As we explore these ancient stellar congregations, we also uncover stories of interaction and migration within the Milky Way. The gravitational forces at play in the galaxy can cause stars to be stripped from globular clusters, sending them on new trajectories through the galaxy. These interactions contribute to the mixing of stellar populations and the distribution of elements, further fostering the dynamic nature of the Milky Way. In addition to star formation and ancient clusters, the Milky Way also offers a canvas for observing the intricacies of cosmic dust. This interstellar dust plays a crucial role in the life cycle of stars and the formation of planets. It absorbs and scatters light, helping to regulate the temperature of interstellar space and influencing the chemistry of the galaxy. Despite its often obscuring nature, cosmic dust is essential for the formation of new stars and planets. It serves as a kind of cosmic compost, breaking down elements from previous generations of stars and recycling them into new celestial bodies. Interestingly, while cosmic dust can make observations challenging by blocking visible light, it also allows astronomers to study the galaxy in different wavelengths. Infrared telescopes, for instance, can peer through dust clouds to reveal hidden star-forming regions and other structures otherwise concealed by the dusty veils. This duality of obscuring and revealing makes cosmic dust a fascinating subject of study, as it underscores the interconnectedness of all elements within the galaxy. Additionally, this cosmic dust is not just lifeless material. It is composed of tiny grains, silicates, carbon compounds, and even ices, which can become the seeds for planets and, potentially, for life. As these dust particles coalesce under gravity, they form protoplanetary disks around young stars. The study of these disks and the dust within them provides clues about how planetary systems, including our own, might have formed. As we contemplate the intricate dance of stars, clusters, and dust within the Milky Way, one cannot help but reflect on the philosophical implications of these cosmic processes. The galaxy is a living entity, constantly renewing itself through cycles of creation and destruction. It embodies change and continuity, a reminder of the impermanence and resilience of all things. As you consider your place in this vast cosmos, think of the countless generations of stars that have lived and died to create the elements that form your body and the world around you. This reflection invites a deeper appreciation for the interconnectedness of all things. Every atom in your body was once part of a star, a testament to the unity of the universe. The Milky Way, with its billions of stars, each a potential host for new worlds and new life, stands as a beacon of possibility and wonder. Its complexity challenges us to continue exploring, to seek answers to the questions of existence, and to embrace the journey of discovery with an open heart and mind. In our pursuit of understanding, let us also be mindful of the responsibility that comes with knowledge. As stewards of our planet and explorers of the cosmos, we hold the power to shape the future of our galaxy. Let this awareness guide our actions and inspire us to preserve the delicate balance that sustains life on Earth, and to ensure that our explorations respect the integrity of the celestial realms we venture into. The Milky Way is not just a vast collection of stars and planets. It is a story, a history, and a promise of what is yet to come. As we delve deeper into its mysteries, may we find not only scientific answers, but also a sense of belonging and purpose in the magnificent tapestry of the cosmos. This galaxy, with its luminous beauty and endless opportunities for exploration, is a reminder of the endless potential that exists within us all. Let me share something interesting about the Milky Way that you might not have encountered before. Our galaxy, with its immense beauty and complexity, also serves as a vast laboratory for the study of cosmic phenomena. One of the most captivating aspects of our galaxy is its role as a generator of cosmic rays. These high-energy particles travel through space at nearly the speed of light and originate from various cosmic events, such as supernova explosions. As these particles enter the Milky Way, they interact with the magnetic fields and the interstellar medium, creating a kind of cosmic symphony that is both fascinating and complex. Cosmic rays are not just visitors to our galaxy, they are integral to its structure and development. They contribute to the ionization of atoms in the interstellar medium, influencing the formation of new stars and planets. Scientists continue to study these particles to understand their impact on both the galaxy and the cosmos at large. The journey of cosmic rays is a testament to the interconnectedness of cosmic events, as they can traverse vast distances, carrying with them information about their origins and the environments through which they have traveled. Speaking of cosmic travels, have you ever considered the role of the galactic habitable zone? Similar to the concept of the habitable zone around a star, the galactic habitable zone is a region within the Milky Way that is thought to be conducive to the development and sustenance of life. Situated at a safe distance from the tumultuous activity near the galactic core, this zone offers a more stable environment with a reduced risk of destructive cosmic events. It is in this zone that our own solar system resides, offering a vantage point from which to explore the galaxy's wonders. The idea of a habitable zone on a galactic scale expands our understanding of life in the universe. It suggests that the conditions necessary for life are not just dependent on a star and its planets, but also on their position within the galaxy. This broader perspective invites us to reflect on the delicate balance that allows life to flourish and the myriad factors that contribute to this cosmic harmony. As we explore other star systems within this habitable zone, we may uncover new potential for life and deepen our appreciation for the conditions that make life on Earth possible. Here's a fascinating fact about the Milky Way's role in the larger cosmic web. The galaxy is not an isolated island in the universe. It is part of a vast network of galaxies, interconnected by mysterious filaments of dark matter and intergalactic gas. This cosmic web is the largest structure in the universe, with threads stretching across billions of light years, holding clusters of galaxies like pearls on a string. The Milky Way is nestled within one of these threads, part of a local group of galaxies that influence each other through gravitational interactions. This interconnectedness highlights the dynamic nature of the universe and the ever-evolving relationships between galaxies. Gravitational forces shape the movement and growth of galaxies, leading to mergers and interactions that can trigger bursts of star formation or even create new structures within the galaxies themselves. The Milky Way's place within this cosmic web offers a unique perspective on the forces that govern the universe and the interconnected paths that stars and galaxies follow over cosmic timescales. Consider this: although we often focus on the visible stars and structures in our galaxy, much of the Milky Way's mass is actually hidden from view. The interstellar medium, composed of gas and dust, plays a crucial role in the galaxy's life cycle, serving as both a cradle for star formation and a repository of the galaxy's history. Within this medium, complex molecules form, including organic compounds that are the building blocks of life. These molecules can travel vast distances, seeding star-forming regions with the ingredients necessary for the birth of stars and planets. The study of the interstellar medium not only reveals the processes that drive the galaxy's evolution, but also sheds light on the potential for life beyond Earth. By analyzing the molecular compositions within these regions, scientists can gain insights into the chemistry of distant worlds and the likelihood of life as we know it existing elsewhere in the galaxy. This continuous cycle of formation, destruction, and renewal within the interstellar medium underscores the dynamic and interconnected nature of the Milky Way, painting a picture of a galaxy in constant motion. Reflecting on these cosmic processes, you might wonder about the role of supernovae in shaping the Milky Way. These explosive events mark the end of a star's life cycle and have profound effects on their surroundings. When a star explodes as a supernova, it releases an immense amount of energy and enriches the surrounding space with heavier elements forged in its core. These elements, including iron and oxygen, are essential for the formation of new stars, planets, and even life itself. Supernovae act as cosmic catalysts, driving the chemical evolution of the galaxy and influencing the formation of subsequent generations of stars. They can also trigger the collapse of nearby gas clouds, initiating new waves of star formation. In this way, supernovae are both destroyers and creators, playing a vital role in the ongoing cycle of cosmic renewal that characterizes the Milky Way. The remnants of these stellar explosions, such as neutron stars or black holes, continue to influence the galaxy long after the initial burst of energy has faded. As you ponder these cosmic phenomena, consider the human endeavor to understand the Milky Way and our place within it. The quest to explore and comprehend our galaxy has driven technological advancements and fueled our curiosity about the universe. From ancient astronomers mapping the night sky to modern scientists using powerful telescopes and spacecraft, each discovery adds a new layer to our understanding of the Milky Way's complexities. This pursuit of knowledge is a testament to the resilience and ingenuity of the human spirit. It reflects our deep-seated desire to connect with something greater than ourselves and to unravel the mysteries of the cosmos. As we continue to explore the Milky Way, we are reminded of the infinite possibilities that lie beyond our planet and the collective journey of discovery that unites us all. Each revelation brings us closer to answering fundamental questions about our origins, our purpose, and the nature of the universe itself. In contemplating the vastness of the Milky Way, we are drawn into a reflection on the interconnectedness of all things. Every star, every particle of dust, and every cosmic event contributes to the tapestry of the galaxy, weaving a story of creation, destruction, and renewal. It is a story that echoes through time and space, inviting us to consider our own place in the universe and the legacy we will leave for future generations. As you settle into the rhythm of these cosmic wonders, let the awareness of the Milky Way's beauty and complexity inspire you. Embrace the knowledge that you are part of a grand cosmic tapestry, woven from the same elements that light up the night sky. This connection to the galaxy and the universe at large reminds us of the shared journey we are all on, a journey of exploration, discovery, and wonder. Reflecting on the vast tapestry of the Milky Way, one cannot help but marvel at its intricate beauty and the myriad phenomena that shape its very existence. The galaxy, with its sprawling arms and luminous bands stretching across our night sky, is a constant reminder of the cosmos's grandeur. As we explore these celestial wonders, let's delve into the role of gravitational waves. These ripples in space-time, first predicted by Albert Einstein, have been detected emanating from cataclysmic events such as the merging of black holes and neutron stars. These waves travel across the universe, subtly shaking the fabrics of our galaxy and contributing to the grand symphony of cosmic forces. Now, consider the influence of magnetic fields within the Milky Way. These invisible forces weave through the galaxy, guiding charged particles and affecting the course of cosmic rays. While most magnetic fields are weak, they play a crucial role in shaping the dynamics of star formation and the behavior of interstellar matter. The interplay between gravity and magnetic forces crafts the delicate balance that holds galaxies together, allowing stars to form and evolve over time. Speaking of star formation, Have you ever pondered the unique characteristics of variable stars? These fascinating celestial objects undergo regular changes in brightness, driven by pulsations in their outer layers or by eclipses in binary star systems. One well-known type is the Cepheid variable, whose brightness variations are linked to their pulsation periods. By studying Cepheids, astronomers can calculate distances within the galaxy and beyond, offering a cosmic yardstick to map the universe's vastness. As you absorb the wonders of these stellar phenomena, think about the intriguing concept of rogue planets. These are planetary bodies that roam the galaxy independently, having been flung out of their original star systems by gravitational interactions. Although these planets drift through the void without the warmth of a sun, they offer a window into the processes that govern planetary formation and evolution. In considering the Milky Way's intricate dance, let's not overlook the remarkable Oort cloud. This theoretical shell of icy objects envelops our solar system and is thought to be the source of many comets. When disturbances, perhaps from nearby stars or galactic tides, send these objects hurtling towards the inner solar system, we witness spectacular cometary displays. The study of the Oort cloud enriches our understanding of the early solar system and the formation of comets. Reflecting on the interconnectedness of these cosmic elements, contemplate the enigmatic quasars. These distant celestial objects are powered by supermassive black holes at the centers of young galaxies, accreting vast amounts of matter. Quasars emit extraordinary amounts of energy, outshining entire galaxies and serving as beacons that illuminate the early universe. Observing these luminous objects allows scientists to peer back in time, unraveling the history of galaxy formation. The gentle glow of the Milky Way also holds clues to the mysterious phenomenon known as gravitational lensing. When a massive object, such as a galaxy cluster, lies between us and a distant source of light, it acts as a lens, bending and magnifying the light. This effect not only allows us to study galaxies otherwise too faint to see, but also provides insights into the distribution of dark matter within these massive clusters. In pondering the galaxy's many mysteries, let's bring into focus the intriguing hypervelocity stars. These rare stars travel through space at incredible speeds, often exceeding 1,000 kilometers per second. Many are thought to have been flung from the Milky Way's center after interactions with the supermassive black hole Sagittarius A. Such stars offer insights into the gravitational dynamics at play in galaxy cores and the powerful forces capable of propelling stars across the cosmos. Take a moment to appreciate the delicate interplay between galaxies within the local group, a collection of more than 50 galaxies that includes the Milky Way, the Andromeda Galaxy, and the Triangulum Galaxy. Gravitational interactions between these celestial neighbors influence their shapes, trajectories, and even their fates as they slowly drift towards one another in a cosmic ballet that will eventually lead to mergers and new galactic structures. As you consider these massive cosmic forces, think about the galactic fountains. These phenomena occur when supernova explosions or intense star formation events in the Milky Way's disk drive hot gas outwards, forming arched trajectories that eventually rain back down. This cyclical process of gas expulsion and accretion contributes to the galaxy's chemical evolution, enriching its disk with heavier elements essential for new stars and planets. In the grand tapestry of the cosmos, it's fascinating to learn about the stellar nurseries found in the Milky Way's spiral arms. These are regions where new stars are born, fueled by the collapse of gas clouds under gravity. As these stellar infants ignite and begin to shine, they illuminate their surroundings, creating stunning nebulae visible across vast distances. These nurseries are the cradles of life for stars, planets, and potentially life itself, providing a glimpse into the ongoing cycles of cosmic creation. While we continue to explore these cosmic wonders, let's also reflect on the profound impact of astrochemistry in understanding our galaxy. This field of study examines the chemical compositions of celestial bodies and the processes that govern the formation of complex molecules in space. By analyzing spectral lines from distant stars and nebulae, scientists can uncover the abundance of vital elements such as carbon, nitrogen, and oxygen, which are necessary for life. The Milky Way, with its countless stars and swirling clouds of gas and dust, serves as a vast laboratory where the laws of physics and chemistry intertwine to create the elements that compose our universe. As our understanding of these processes deepens, we come closer to unraveling the mystery of life's origins and potential existence beyond Earth. Through all these cosmic connections, the Milky Way reminds us of the boundless possibilities of discovery and the intricate web of life that extends from the smallest particle to the grandest galaxy. Each fact we uncover, each mystery we unravel, adds to the profound tapestry of knowledge that binds us to the universe and to each other. As we contemplate the Milky Way's wonders, we embrace a shared journey of exploration, understanding, and wonder, connecting us across time and space to the cosmos's majestic expanse. The night sky, a canvas painted by the infinite artistry of our universe, invites us to ponder its vast mysteries. The Milky Way, our celestial home, stretches across the heavens, a luminous band that becomes a familiar yet awe-inspiring sight in regions blessed with dark skies. Let me share something curious. The appearance of the galaxy changes with the seasons, offering different views throughout the year. As Earth orbits the Sun, our vantage point shifts, revealing new portions of this stellar tapestry, each adorned with unique constellations and cosmic wonders. In the quiet moments under this stellar dome, consider the Milky Way's role as a cosmic archive. It holds stories written over billions of years, from its earliest formations to the complex structures that now span its breadth. One of my favorite facts is about the galaxy's halo. This vast spherical region of hot gas extends far beyond the visible edges of the galaxy. It serves as a protective bubble, containing clues about the galaxy's formation and evolution. While the halo is mostly invisible to us, it may have a mass that equals or even exceeds the visible parts of the Milky Way, hinting at the unseen forces that bind our galaxy together. Did you know that the Milky Way is not just a single entity but a collection of stars, gas, dust, and dark matter, all interacting in a delicate balance? These components, while distinct, are deeply interconnected. The materials that form our bodies once resided in the hearts of stars, forged in the intense heat and pressure of stellar cores. These elements, through processes like supernovae, were scattered across the galaxy, seeding future generations of stars and planets. This cycle of birth, death, and rebirth fosters a profound sense of continuity, linking us to the ancient stars that once shone brightly in the cosmic night. Speaking of continuity, the Milky Way's spiral arms are a testament to the dynamic nature of our galaxy. They are not rigid structures, but waves of density that nurture star formation, creating the appearance of arms that spiral gracefully from the core. Within these arms lie not only stellar nurseries, but also pockets of ancient wisdom. Older stars, remnants from earlier galactic phases, provide a living record of the galaxy's history, enriching our understanding of its past and guiding us in predicting its future. Interestingly, as the Milky Way journeys through the cosmos, it is part of a larger ensemble known as the Local Group. This close-knit family of galaxies drifts through space, gravitationally bound to one another. Over astronomical timescales, these galaxies will continue to interact, their paths gently guided by the gravitational dance that plays out on a cosmic stage. This intergalactic choreography reminds us that while galaxies are vast and often isolated, they are not alone. Their interactions shape their destinies, much like the connections we form in our own lives. Consider this. The Milky Way is but one of billions of galaxies scattered throughout the universe, each with its own unique story. Yet despite this incomprehensible number, each galaxy is a cosmos unto itself with its intricate structures and phenomena. Our understanding of the Milky Way, with all its complexity, is a testament to human curiosity and our relentless drive to explore. Through the lens of science, we have transformed points of light into a rich tapestry of knowledge, revealing the galaxy's wonders and mysteries. One of the galaxy's intriguing aspects is its role as a crucible for astrochemistry. This field delves into the chemical compositions of celestial bodies, exploring how complex molecules form in space. By studying the spectral lines from distant stars and nebulae, scientists can uncover the abundance of elements like carbon and oxygen, essential ingredients for life. These discoveries connect us to the broader narrative of life in the universe as we seek to understand not only how life began on Earth, but whether it might exist elsewhere in the cosmos. The more you learn about the Milky Way, the more you realize how much there is yet to discover. Each new observation and insight adds depth to our understanding, creating a mosaic that reflects both the galaxy's beauty and its profound complexity. As we continue to explore, we remain grounded in the realization that the Milky Way, with all its majesty, is a part of a larger cosmic story, one that continues to unfold with every passing moment. Through the gentle glow of the Milky Way, we are invited to dream and to wonder. We find ourselves peering into the depths of the universe, where each star, each nebula, and each dark matter halo plays its part in a grand cosmic dance. This interconnectedness speaks to the unity of the universe and our place within it, reminding us that we are all stardust, born from the same cosmic furnace. The night sky, with its countless stars and swirling galaxies, offers a serene reminder of our shared journey. As we gaze upward, we're connected to those who have looked at these stars before us, bridging time and space. This connection enriches our understanding, not just of the cosmos, but of ourselves. The Milky Way, in its quiet, patient way, whispers stories of creation, evolution, and endless possibility, inviting us to listen and to learn. As you continue to ponder the Milky Way's wonders, let these thoughts gently guide you into a state of calm reflection. The universe, in its vastness, offers a comforting reminder of our place in the grand scheme, hinting at the infinite possibilities that lie ahead. And within this cosmic embrace, may you find peace and wonder as the galaxy's wonders softly illuminate the night. As we find ourselves nearing the end of this cosmic journey through the Milky Way, let us take a moment to reflect on the vast tapestry of knowledge we've woven together. Each fact, a delicate thread, contributes to our understanding of this immense galaxy. The Milky Way is not merely a collection of stars, gas, and dust, but a dynamic entity, teeming with unseen forces and celestial phenomena that continue to inspire wonder. Here's something you might find intriguing. Within our galaxy, there are stars known as hypervelocity stars. These are not your ordinary celestial bodies. A surprising twist of fate sends them hurtling through space at incredible speeds, sometimes reaching over 1,000 kilometers per second. Their journeys begin near the galaxy's core, perhaps ejected by interactions with the supermassive black hole, sending them on a trajectory that may one day see them leave the Milky Way entirely. This process reminds us of the incredible forces at play in our galaxy, where even the stars themselves are not immune to the cosmic dance of gravity. Consider the enigmatic dark matter, a key player in the galaxy's structure. While invisible to our eyes and our most powerful telescopes, its influence is unmistakable. Dark matter forms a halo around the Milky Way, providing the gravitational glue that holds everything together. Without it, our galaxy would be a very different place, its spiral arms and the stars within them unable to maintain their graceful formations. In a way, dark matter serves as a reminder that often the most significant forces in our lives are those we cannot see, yet their presence is felt, shaping our experiences and our world. Speaking of unseen influences, let's turn our attention to the role of magnetic fields in the Milky Way. Threads of magnetic energy weave through the galaxy, affecting everything from the trajectories of cosmic rays to the birth of stars. These fields are not uniform but instead vary in strength and direction, creating a complex network that influences the behavior of charged particles. This hidden tapestry of magnetism adds another layer to the intricate beauty of our galaxy, a reminder of the complexity lying beneath the visible surface. As we gaze into the night sky, it's astounding to realize that the light from some stars began its journey billions of years ago, long before the Earth even existed. When you look up at the Milky Way's band, you are witnessing the history of the universe itself, a time capsule of light that connects us to the very origin of the cosmos. Each star tells a story, a narrative of creation and transformation, urging us to contemplate our place within this vast and wondrous universe. In contemplating our cosmic address within the Milky Way, we find ourselves part of an ever-evolving narrative. This galaxy has witnessed the birth of stars, the formation of planets, and the emergence of life. It tells a story of creation, change, and resilience that mirrors our own journey on Earth. As we stand on the shoulders of the countless astronomers and dreamers who have come before us, we continue to explore and understand the universe, driven by the same curiosity that compels us to look upward and wonder. The Milky Way's legacy of exploration and discovery is not merely a scientific pursuit, but a deeply human one, rooted in our desire to understand our origins and our future. In this galaxy we find both a mirror and a guide, reflecting the beauty and complexity of existence. As we learn more about the Milky Way, we also learn about ourselves, our connections to one another, and our shared journey through time and space. As our exploration of the Milky Way draws to a gentle close, may you hold on to this sense of wonder and curiosity. Let it guide you, not just through the cosmos, but through life's many adventures. Continue to seek the stories hidden within the stars and the mysteries waiting to be uncovered. And as you close your eyes tonight, let the quiet whispers of the Milky Way guide you into restful dreams. Thank you for joining me on this journey through the galaxy. Your curiosity keeps the spirit of discovery alive, and there's always more to learn in this boundless universe. If you find comfort in the stars and joy in these cosmic stories, consider subscribing and joining future explorations. Until next time, may the peace of the night sky cradle you gently. Good night and sweet dreams.